Hello and welcome back to the channel Science, Maths and Engineering. Today we are going to solve the second part of this mechanical engineering paper, the examination for which was conducted by the Directorate of Technical Education Assam for the post of Assistant Professor in 2020. As we already discussed that all questions in this paper were from previous year gate question papers, and a pie chart is shown to give an idea of the number of questions from each year. So let's get started. A coin is tossed thrice. Let X be the event that head occurs in each of the first two tosses. Let Y be the event that a tail occurs in the third toss. Let Z be the event that two tails occurs in three tosses. Based on the above information, which of the following statement is true? A. X and Y are not independent. B. X and Z are independent. C. Y and Z are independent. Or D. Y and Z are dependent. So the answer is C. If the first two tosses are heads, the third toss can be a tail or a head. So the event that the third toss is a tail is also possible. So X and Y are independent. Next, X, if two heads occurs in the first two tosses, then two tails cannot occur in three tosses. So X and Z are dependent. Next, Y and Z, if we see, Y is that a tail occurs in the third toss and Z is the event that two tails occurs in three tosses. So tail head tail or head tail tail are possible. So Y and Z are independent. So option C is the correct answer, that is Y and Z are independent. Next question. Critical damping is the, so what is critical damping? So let us see. See here, the damping ratio zeta, if it is less than 1, then we have the vibration dies down is periodic and dies down slowly. If zeta is equal to 0.1, then we can see that it slows down, it dies down very slowly and we have a certain number of oscillations. Then if we increase zeta to 0.5, there is this green one line, we see that it decreases and then increases a bit and then dies down. However, if critical damping, there is zeta equal to 1 is applied, then we see that this purple color, that it dies down without any oscillation and instantly, very fast. And if zeta is equal to 2, then what happens is that the vibration dies down without any oscillation, but it takes more time than the critical damping. So critical damping is the smallest amount of damping for which no oscillation occurs in free vibration. Next question. Which of the following is not a rotating machine? A. Centrifugal pump, B. Gear pump, C. Jet pump, or D. Vane pump. C. Centrifugal pump is a rotating machine. Gear pump is a rotating machine. Vane pump is also a rotating machine. However, jet pump is not a rotating machine. It is a reciprocating machine and it can lift water up to 60 meters. It has a low efficiency of around 25% and can be used to take out muddy water, lift from wells of small bores, and also can be employed in mining and for pumping oil. Next, consider a truss PQR loaded at P with a force F as shown in the figure. The tension in the member QR, this member QR is, so let us see. See, this is done by the method by applying at the points the summation of the forces and the moments equal to 0. So here no moment we are applying, we are applying the forces. You see, F is here. So this is the diagram and this is the free body diagram. So P, Q and R. At Q and R there are reaction forces RQ and RR, and then we have F of PQ in this member, F of PR in this member, and F of QR in the third member. So you see at this point summation of F of H equal to 0. So F of PQ sine of 45 degree would be equal to F of PR sine of this angle is 60 degree. So from here we find that F of PQ is equal to root over 3 by 2 F of PR. Next, if we see at this point again P and we see the summation of vertical forces equal to 0. So what we have is that F of PQ into cos of 45 degree plus F of PR into cos of 60 degree minus this F would be equal to 0. So from here we get that F of PR is equal to 2 by root 3 plus 1 F. Next, if we see at this point R, F of PR cos 30 degree minus F of QR would be equal to 0. So f of qr would be equal to, once we substitute the value of f of pr, so we get f of qr would be equal to root 3 by root 3 plus 1f, which is equal to 0.63f. Next, match the following: fillet gauge, snap gauge, and cylindrical plug gauge. And then we have on the right hand side we have radius of an object, diameter within limits by comparison, clearance or gap between components, and inside diameter of stage hole. So let us see. The filler gauge, these are filler gauges. So these are used to check the clearance between two mating parts. Okay, like the clearance between a piston and a cylinder can be checked with these gauges. So we check one by one which gauge fits the base. So that gauge would give us the clearance for this piston and cylinder. Okay. Next, it can also be used for the gap between these distributor points of a automobile. Okay. Next, this is a fillet gauge. Fillet gauge, it is used to check the radius of an object. Next, we have snap gauge. It is used to check the upper and lower limit of a diameter of cylindrical object. As we can see, this is the no go and this is go. So once you can check the upper and lower limit of any diameter like cylindrical object. Okay. So next, cylindrical plug gauge. It is used to check the size limits of straight cylindrical hole. So this is the diagram of a cylindrical plug gauge. Next, so here our option A would be the correct answer. So next question: in matrix equation Ax equal to R, A is given, X is given, R is given. So one of the eigenvalues of the matrix A is, so let us see. See, the roots of the characteristic equation A minus lambda I is equal to 0 are known as the eigenvalues of the matrix A. So Ax equal to lambda x. Now we are given that Ax equal to R. So from here, if we simplify, we get that Ax is equal to 16x. So that means lambda would be equal to then 16. So one of the eigenvalues of the matrix is 16. Next, consider a linear elastic rectangular thin sheet of metal subjected to uniform uniaxial tensile stress of 100 megapascal along the length direction. Assume plane stress condition in the plane normal to the thickness. Young's modulus is given, Poisson ratio is given, and the principal strains in the plane of the stresses are to be determined. So let's see. See, sigma 1 is 100 megapascal, sigma 2 and sigma 3 are 0, nu is 0.3, that is Poisson ratio, and E, that is Young's modulus, equal to 200 megapascal. We know epsilon 1 is equal to sigma 1 by E minus nu into sigma 2 by E. Similarly, epsilon 2 is equal to sigma 2 by E minus nu into sigma 1 by E. So substituting the values, we get that the principal stresses in the plane of the sheets are what? 0.5 and minus 0.15. Next question. Endurance limit of a beam subjected to pure bending decreases with. So you see, the endurance limit for rough and corroded surfaces is lower as compared to smooth and polished surfaces. Okay. Next, once the size of the beam increases, it leads to what? Higher voids and volumetric defect. Thus, this reduces the endurance limit. So, the answer is that the endurance limit of a beam subjected to pure bending decreases with increase in the surface roughness and increase in the size of the beam. So, option D. Next question. Hardenability of steel is a measure of. So, what is hardenability? So, hardenability of steel is a property that determines the depth and distribution of hardness induced by quenching. So, more is the martensite formation, the more is the hardenability of the material. So, our option D, that is the depth. So, hardenability of steel is a measure of the depth to which required hardening is obtained when it is austenized and then quenched. Okay. Next question. Which one of the following statements is true for ultrasonic machining? A. Ultrasonic machining often uses a slurry comprising abrasive particles and water. B. Ultrasonic machining does not employ magnetostrictive transducer. C. Ultrasonic machining is an excellent process for machining ductile materials. And D. In ultrasonic machining, the tool vibrates at subsonic frequency. So the answer is C. Ultrasonic machining uses a slurry comprising abrasive particles and water. It is true. And this slurry should be harder than the material being machined. Next, in ultrasonic machining, what we do is that we use electrical energy and convert it to vibratory motion, and for this a transducer is used. Now this transducer uses piezoelectric or magnetostrictive principle. So option B, that is USM does not employ magnetostrictive transducer, is false. Next, USM is used for electrically non-conducting, semiconductive and brittle materials. So USM is not used for ductile materials. And next, in USM, a tool vibrates at ultrasonic frequency of the range of 20 to 30 kilohertz. Okay, so which is very well above the audible frequency range. So option D, that it vibrates at sonic frequency, it's false. So next question. A self-aligning ball bearing has a basic dynamic load rating of 35 kilonewton. If the equivalent radial load on the bearing is 45 kilonewton, the expected life is, the answer is, see, we know rated bearing life is equal to capital C by capital P to the power small p. So C is dynamic load capacity and capital P is the load applied, and small p is 3 for ball bearing. So if therefore L would be equal to 0.47. So the expected life is below 0.5, that is option C. Next question. Which one of the following statements about a phase diagram is incorrect? A. Solid solubility limits are depicted by it. B. It gives information on transformation rates. C. It indicates the temperature at which different phases start to melt. And D. Relative amounts of different phases can be found under given equilibrium conditions. So the answer is that a phase diagram does not give information on transformation rates, and for transformation rates we have the time temperature transformation or TTT curve, and all other options were true. Next, match the following part programming codes with their respective functions. So see, we have Z1, Z3, M5, M3 and M5. The answer, you see, here I have given the codes for with the functions for around 10 codes. So Z1 is for linear interpolation, Z3 is for circular interpolation anti-clockwise, M3 is for spindle on clockwise, and M5 is for spindle stop. You can also check the other codes. So option B is the correct answer. Next, the velocity triangles at the inlet and exit of the rotor of a turbo machine are shown. V denotes the absolute velocity of the fluid, W denotes the relative velocity of the fluid, and U denotes the blade velocity. Subscripts 1 and 2 refer to inlet and outlet respectively. If V2 is equal to W1 and V1 equal to W2, then the degree of reaction is, so in this figure you can see that U is same for both, so U1 would be equal to U2. Now degree of reaction R is given by this equation. So once we put U1 equal to U2, V2 equal to W1 and V1 equal to W2, we get the reaction is equal to 1 by 2 or 0.5. Okay, so our answer is 0.5. Next question. It is desired to make a product having T-shaped cross section from a rectangular aluminum block. Which one of the following processes is expected to provide the highest strength of the product? A. Metal forming, B. Casting, C. Welding, or D. Machining. So the answer is the metal forming would give the highest strength, as due to plastic deformation the grain structure of the metal align, resulting in improved strength of the product. Also in metal forming we are not losing any of the material of the rectangular block, so it also will have the highest density. However, in welding, casting and machining, in welding, as we see with our joints, although we are joining but we cannot join throughout the surface, so the weld is not of that strength as it comes from metal forming. Again, casting will have casting defects, so the strength is again less. And in machining we are reducing, we are cutting a part of the block to make the T shape, so again machining will not give us that much strength that metal forming can give. So next question. If x is the mean of data 3, x, 2 and 4, then the mode is, the answer is Cx is the mean of the data 3, x, 2 and 4. So x is equal to 3 plus x plus 2 plus 4 by 4. So from here we get x is equal to 3. So our data is now 3, 3, 2 and 4. So 2 has a frequency of 1, 3 has a frequency of 2 and 4 has a frequency of 1. So as the data 3 has the highest frequency, so our mode is 3. Next question. A solid cube of side 1 meter is kept at a room temperature of 32 degrees centigrade. The coefficient of linear thermal expansion of the cube material is 1 into 10 to the power minus 5 per degree centigrade and the bulk modulus is 200 gigapascal. If the cube is constrained all around and heated uniformly to 42 degrees centigrade, then the magnitude of volumetric stress in megapascal induced due to heating is, so it is constrained and we are heating it by around 10 degree and we need to find out the volumetric stress. The answer is, see, the cube is constrained, so cube cannot expand. So we have compressive forces developed in the walls of the cube. Now due to symmetry, sigma x would be equal to sigma y equal to sigma z. This is equal to minus sigma. Then if it is not constrained, then sigma x would be equal, then epsilon x would be equal to epsilon y equal to epsilon z equal to epsilon. Now let L be the length of each side of the cube. Now without constraint, as the cube is heated by delta T, so the expansion of the cube would be delta L is equal to alpha L into delta T. Now strain would be equal to delta L by L, so which is equal to alpha into delta T. Now volumetric strain would be equal to sum of the all strains, so that would be equal to 3 alpha delta T. Now with constraint, volumetric strain would be equal to sigma V is equal to direct stress by bulk modulus, so it is sigma V by K. So from here we get sigma V is equal to 3 alpha K del T. So from here we get sigma V is equal to 60 megapascal. So option D is the correct answer. Next. In a linearly hardening plastic material, the screw stress beyond initial yielding. So how does it behave? So this is the graph for true stress beyond initial yielding, true stress and screw strain. So you can see that the true strain stress beyond initial yielding increases linearly with the true strain. So this is the line. So it increases linearly. Next question. Equal amounts of a liquid metal at the same temperature are poured into 3 molds made of steel, copper and aluminium. The shape of the cavity is a cylinder with 15 millimeter diameter. The size of the molds are such that the outside temperature of the molds do not increase appreciably beyond the atmospheric temperature during solidification. The sequence of solidification in the mold from the fastest to slowest is, so we are given the thermal conductivities of steel, copper and aluminium. Then we are given specific heats and the densities of all these 3 metals. So we need to find out which will solidify the fastest and which will solidify the slowest. So the answer is, see, heat diffuses faster through a metal which have higher thermal diffusivity. And so the metal with highest thermal diffusivity will solidify in the quickest time. So thermal diffusivity alpha is equal to K by rho C. So we K and rho C are given for all these metals. So we can find out. So alpha of steel is 17.749 into 10 to the power minus 6. Alpha for copper is 116.597 into 10 to the power minus 6, and for aluminium is 97.207 into 10 to the power minus 6 meter square per second. So copper will solidify the fastest, then aluminium, and then steel. So next question. A mass m of a perfect gas at pressure P1 and volume V1 undergoes an isothermal process. The final pressure is P2 and volume is V2. The work done on the system is considered positive. If R is the gas constant and T is the temperature, then the work done in the process is, the answer is, see, work done in the isothermal process is W is equal to P1 V1 into log of P2 by P1. So which is equal to then minus of P1 V1 into log of P1 by P2. Now as it is isothermal, so P1 V1 would be equal to MRT. So we get W is equal to minus MRT into log of P1 by P2. So option B is the correct answer. So with this we have come to an end to this second part of this mechanical engineering paper, which was conducted by the Directorate of Technical Education Assam for the post of assistant professor in 2020. So we will soon come with the later parts. Stay tuned with the channel and see you in the next one.